Okay, so now that we have talked about moles and mole conversions, we can focus back on solutions. We have discussed several different ways in which we can determine the concentration of a solution. We have described concentrations as solute within a solution by using words such as unsaturated, supersaturated, dilute, and concentrate. We have quantitatively calculated the percent concentration of a solution by using the mass percent calculation. Now we are going to discuss ways in which to describe the constitution using molarity and molality. Our objective for today's video is that we can define and calculate both molarity and molality. So let's dive in. In a solution, it's often more convenient to use the measurement of volume for the total solution as opposed to grams. In order to determine the concentration in terms of volume, we must use molarity. Molarity is defined as the moles of solute over the liters of solution and is abbreviated with a capital M. So, a 1 molar solution of hydrochloric acid would be written as 1.0 capital M HCl. HCl is the chemical formula for hydrochloric acid. If you have not already figured out by now, the formula for molarity is molarity equals moles of solute divided by volume of solution. So capital M equals moles divided by volume. Some things you may need to know with molarity is that you need to pay attention to the units. You have to have a solute in moles in order to do this. That means if you are given grams of a solute, you must be able to convert them to moles. So let's do a practice problem. Determine the molarity of a solution by dissolving 13.2 grams of sodium chloride in 2 liters of solution. So we know the molarity formula is molarity equals moles of solute over liters of solution. Okay, we have the liters of solution, but we do not have the moles of solute. Instead, we have it in grams, so we're going to have to convert it to moles. So here's our pathway for solving this problem. First, we are going to convert our grams to moles. Then, once we have our moles of solute, we can plug it into our molarity formula. In order to convert 13.2 grams of sodium chloride into moles, we are going to find the formula mass. If you forgot how to find the formula mass and convert mass to moles, then click the card that's probably coming across the screen about now. Going back to solving this problem, we make the formula mass chart for NaCl, for sodium chloride. In doing this, we find that there is 57 grams of sodium chloride per 1 mole of it. Now, we have to put our 13.2 grams of sodium chloride over 1 and multiply it by 1 mole over 57 grams. When we do that, we get 0.23 moles of sodium chloride. Now we know our moles of sodium chloride or our moles of solute. We can plug that into our molarity equation. So it should read molarity equals moles of solute over liters. This turns out to be 0.23 moles of sodium chloride over 2 liters of solution. By dividing it out, we get a 0.115 molar solution of sodium chloride. Now let's talk about one more unit of measurement of concentration that's very similar to molarity. Molality is the moles of solute dissolved in kilograms of solution. So we got difference molarity and molality. It's very close in verbiage, but they are different in their formulas. It is represented by lowercase m, and the formula would be m equals moles of solute divided by kilograms of solution. So let's work out a practice problem. A sulfuric acid solution contains 600 grams of H2SO4, which is sulfuric acid, in a solution and weighs 1,400 grams. Calculate the molality of this solution. Okay, we know the formula of molality is moles of solute over kilograms of solution. We neither have moles or kilograms, so we are going to have to convert both units in order to get our desired units. Here is a map in which we are going to do to solve this problem. We are first going to convert our grams of H2SO4 or sulfuric acid into moles of sulfuric acid. Then we're going to convert our 1,400 grams of solution into kilograms of solution. Once we have both of them, then we plug it into the molality equation and calculate molality. So here we go. We have 600 grams of solute, And in order to convert it to moles, we need to find the formula mass for sulfuric acid, or H2SO4. We do this with the formula mass table, and we find that the formula mass for H2SO4 is 98 grams per mole. Now we convert our 600 grams into moles by putting 600 grams of H2SO4 over 1 and multiplying it by 1 mole over 98 grams of H2SO4. Once we multiply our tops and bottoms together, we get 600 over 98, which equals 6.12 moles of H2SO4. So now we have our moles of solute. We can move on to our kilograms of total solution. So our next step is going to be put what we know over 1. We know that our solution has a mass of 1,400 grams, and we're going to put that over 1, so 1,400 over 1. Next, we're going to multiply our 1,400 grams over 1 by a relationship of 1 kilogram over 1,000 grams. Once we do this, we get 1,400 over 1,000, which equals 1.4 kilograms for this solution. Our last step is taking our moles of solute and dividing it by our kilograms of solution, so 6.12 moles of H2SO4 over a 1.4 kilogram solution, and we get a molality of 4.37. Okay, so that's the basic for molarity and molality. I think that's probably enough math problems to start you out with. If you need more help with these topics, please go ahead and view my practice problem video over molarity and molality. Outside that, keep up the good work in the classroom, and see you next time.